Hello, and welcome to this edition of Amp-titudes. My name is Kevin Schroeder, product marketer with Microchip Technologies Analog Division. When it comes to monolithic instrumentation amplifiers, or INAs, there are a variety of methods that manufacturers use in order to implement the gain setting. These methods include fixed gain, programmable gain, pin-selectable gain, and using one or two external resistors to set the gain. This edition of Amp-titudes will explore the advantages and disadvantages of each of these gain-setting methods. Fixed gain INAs are very useful in that these devices can be optimized for a specific gain, improving linearity, offset, and gain accuracy for the specific gain that is implemented. These devices can also be placed in smaller packaging, such as a 5-pin SOT23, since additional pins for setting gain are not needed. The obvious downside is that the gain is fixed, meaning it cannot be adjusted by the end user, which limits the device's flexibility. As the name implies, programmable gain amplifiers implement a register set that allows the user to set the gain and possibly adjust other settings as well. These amplifiers typically use a standard I2C or SPI interface that can easily be controlled by a microcontroller. This programmability allows for a much more flexible device, and since the gain resistors are integrated in the IC, gain accuracy can also be optimized. However, such a device requires a microcontroller or other serial interface device and can be a relatively large silicon solution, which adds to the cost. Another option is to make the INA programmable via hardware pins as opposed to a standard serial interface. In this case, the gain is set based on whether the pins are pooled high, low, or high impedance. These devices still require an MCU or other logic device if the gain is to be adjusted on the fly. Using external resistors is a very popular method for setting the gain of a monolithic INA. Some devices allow the gain to be set via one external resistor, while on other devices, gain is set via the ratio of two external resistors. At a glance, it may seem that using one external resistor is better. Eliminating an external resistor saves a little cost, board space, and reduces design complexity. However, there are disadvantages to this single resistor approach. Whether using one or two external resistors, the gain is set via the ratio of two resistors. In the case of a single external resistor, it is the ratio of an internal resistor constructed within the IC and the external resistor provided by the user. This technique requires the internal resistor value to be accurately known, such that the user can set the gain properly. Most manufacturers must trim this internal resistor in order to get this level of accuracy. Another disadvantage is that the internal resistor and external resistor will have different drift characteristics, which will lead to gain errors across time and temperature. Implementing a monolithic INA with two external gain-setting resistors, such as Microchip's MCP6N16, eliminates these concerns. With proper layout, the two external resistors will track very closely over time and temperature, and the accuracy of the ratio of the two external resistors is left entirely up to the user. So the next time your design requires a monolithic INA, be sure to consider the gain-setting methodology and the associated trade-offs. Finally, when it comes to using external resistors to set the gain, remember that less isn't always better. Thank you for joining me for this edition of Amp-titudes. For more information, please visit www.microchip.com/linear. I'll see you next time.